So this is a short demo for using the Web Molecular Orbital WebMO website. It's currently installed on the TCNJ High Performance Computing Center. And so the first thing you have to do is go to the website webmo.hpc.tcnj.edu. This works well. I'm running this in a Firefox web browser on a Mac. This also will work in Firefox on Windows, Safari on Mac, and it should work in Internet Explorer in Windows as well. Google Chrome won't be able to run WebMO um, currently, so you should use one of those mentioned web browsers. So the first thing that you'll do is you'll type in your username and password, and that'll be your TCNJ username and password, and click the login button. Now, if you're a student, you'll see an additional screen which will ask you about a group name and a group password. Your group name should be GenChem, and that should be selectable from a pull-down menu. And your instructor will give you the group password to enter. After you enter that, you should be taken to this WebMO job manager screen as you see here. And so I'm just going to show you quickly how to use some of the basic features of WebMO for constructing molecules. There's also a written tutorial that goes along with the general chemistry exercise that you'll be doing in your laboratory class. So to start a new job in WebMO, all you have to do is go to the New Job pull-down menu and click on Create New Job. And that should take you to a screen which is the Molecule Builder screen. You see that you have a lot of menus here on the top. You have a lot of buttons on the left-hand side. If you hover over one of those buttons briefly, it'll tell you what it does. So for example, this is a button if you want to zoom in and out. This is a button that you can select in order to rotate molecules once you've built them. The one that we'll be using quite a bit is this periodic table button. Over on the left-hand side, there's a link that will take you directly back to the job manager screen if you want to go back and create a new job or look at your job status once it's running. So the first thing we're going to do is we're just going to build a very simple molecule. So we're going to build methane. So if you click on the periodic table, you should see periodic table pop up. You can choose an atom, and so let's go ahead and choose carbon. And if you just click in the screen now somewhere in your window, you'll see that you've just created a carbon atom. Let's go ahead and add a hydrogen atom. I'm going to show you how to do this manually, and then I'm going to show you how WebMO can actually add additional hydrogens automatically. So the next thing we'll do is go ahead and click on the periodic table button again and select hydrogen. And what you can do is you can click on the carbon atom that you've placed and hold your mouse button, and then you can drag your mouse, and when you release, you'll see a hydrogen atom that has now been bonded to the carbon atom dragged at some distance. If I go over here and click on the rotate button, I can go ahead and rotate this around and look at it from a variety of vantage points. Instead of adding the other hydrogens by hand, let's go ahead and use another feature of WebMO, which is under the cleanup menu. And if you go down to cleanup and you select comprehensive mechanics, what this will do is this will add hydrogen atoms to complete the valence, the carbon. And it will also do an initial optimization of the geometry of the molecule. So it'll make its best guess based on some basic physics about what the geometry of this molecule should look like. So let's go ahead and click that, comprehensive mechanics. And you see that it's added the other three hydrogen atoms that you would expect for methane. And it's arranged them actually in a tetrahedral geometry, which you should also expect for the methane molecule. But let's go ahead and go a little bit further because this is what you're going to be doing in the lab exercise that you're carrying out for a variety of molecules. We're going to use a little more rigorous method to optimize the geometry of our methane molecule. And so the next thing that you can do is click on this blue arrow down here in the lower right. This is the continue arrow. We'll go ahead and ignore this comment about symmetrization for now. So go ahead and click OK. And you'll see here that in this menu you have a job name. You can call that whatever you want. You can just leave it as CH4. Under the calculation menu, you'll go ahead and click geometry optimization. So we're going to ask WebMO to further optimize the geometry of the molecule. And so what that means is to try to refine the values for the bond lengths and the bond angles. And if we had a larger molecule, molecular dihedral angles as well. So we choose geometry optimization. For our theory, we're going to go ahead and choose PM6, level of theory. We don't need to worry about that. For now, you can go ahead and leave charge at 0 and your multiplicity as singlet, so just default values. Go ahead and click on the continue arrow. And what this will do is this will submit your job into the supercomputer. And you see here that it says running. So your job is running. This tells you the time that it's taken to run. If you want to refresh the job list, you can click the refresh button. But you see, before I did that, the job has already completed. It only took 1.5 seconds to perform the geometry optimization using WebMO to run a software package called MoPack. And so this actually runs very quickly. The next thing you can do is go ahead and click on the magnifying glass to view your completed job. So let's take a look. And you see now that the molecular geometry as we expect is still tetrahedral, and your atoms are also numbered now. If you scroll down over on the right-hand side, you see that those numbers correspond to these atom numbers here. And you can actually, for example, see what the assigned partial charges to the various atoms are in that molecule. In fact, you can go ahead and click, if you're interested in looking at it, at the dipole moment. And as you expect, for this tetrahedral molecule, it's not going to be very interesting because it's completely symmetric and the dipole moment is exactly 0 as calculated by the MoPack software. But let's go ahead and take a look at how to measure bond angles and bond dihedrals using the WebMO software, which is what we're really interested in for this particular laboratory. In order to do that, we want to make sure that we are in the adjust or select mode. So click on this arrow over here, and then go back over to your screen. And the next thing we're going to do is click the Shift button and click on one of the atoms. So go ahead and click on atom 4, for example, and it'll give you some information down here about that atom. The next thing that you can do is click on the central carbon atom. So if you click on that carbon atom as well, you see now in this lower left corner, it lists the bond length, which is 1.08 angstroms. If you want to look at an angle instead, we can go ahead and click on, for example, atom 4, atom 1, and atom 5. And now, once we've clicked on 3 atoms, we see the bond angle, which is 109.471 degrees. And so you can go through and you can do this for the various other pairs of atoms and triplets of atoms in your molecule as well to get measurements of those bond angles and bond distances. Finally, when you're done, you can go ahead and go back to the job manager. You could create a new job if that's what you want to do in order to continue to proceed through the assignment. And once you're all finished completely, you will just click on log out. And I had some files in my trash that I just got rid of. And that'll take you back to the login screen. So that's just a very basic intro to how to use the WebMO software to build molecules and measure bond angles and distances. This should get you started for using this web-based software for your laboratory in general chemistry this week. Thanks.